So what you're doing on this first part is you're really just using some background knowledge from chapter 2. We know these are all parabolas because the equations have x squareds in them. F of x equals some kind of x squared. That means we have parabolas, and we're just looking at what's going on in the equation. We're moving left and right or up and down, and we're matching those graphs to their equations by using transformations. Yes? Which one? H of x would be left 3, up 1. The plus 3 inside the parentheses on h of x. Are we looking at the same one? H of x?
Oh, okay.
The plus 3 would be to the left 3, and then the plus 1 would be up 1. Does that make sense? Remember, the number inside the grouping symbol is the opposite of what you think. Okay? So they're kind of just going back to something that you already know there. Now, what we're going to do is we're going to get really, really specific with some parabolas here. And we're going to talk about some things that we have talked about. We're also going to talk about some things that we have not talked about. So on that first parabola, it says f of x equals ax squared plus bx plus c. So we kind of know anytime we see an x squared, we know we have a parabola. How about this part that says a is greater than 0? Have you all ever seen anything about a being greater than 0? It was written a is positive. Does that not mean the same thing? If a is greater than 0, a is positive. And that's when the parabola goes up. Okay? So if you'll look at that second example over here, it says a is less than 0. That means a is negative, and then the parabola would go down. And we've talked about a vertex before. We've not really talked a lot about an axis of symmetry, and we'll spend a little bit more time with an axis of symmetry. We're going to get into all kinds of graphs in this chapter. We're going to get into what we call the roller coaster graphs, the crazy roller coaster graphs that look like this. So in order to get there, they're going to go back to a polynomial graph that you've done before. So they're trying to attach some meaning to something that you've already done before. The axis of symmetry of a parabola, since it's symmetric, it does have an axis of symmetry, and that'll just be that imaginary line, that imaginary vertical line that goes right through your vertex. Okay? We'll talk a little bit about this equation, x equals negative b over 2a, but we won't talk a lot about it. But these are just some things that you're supposed to know about a parabola. Alright, now they're going to ask you to match again, but this time a few of these equations are not in what we would call a standard form. They're not really in a form, not all of them. Okay, but 2 of them are not in a form where you can see the transformations. So can y'all guess out of f of x, g of x, h of x, and j of x, which 2 are not in a form that we can just look at it and say, oh, left 2 and up 1? Or which 2 are not in a specific form for you to... H of x and j of x. Okay? You can't tell left, right, up, or down. Okay, but look at f of x. F of x you can. So let's do f of x. Let's match f of x. F of x equals x squared minus 2. The minus 2 is on the outside, so that means we are going where?
Down 2.
Down 2. Is the parabola facing up or is it facing down?
Up.
It's facing up. So f of x is going to match with example 7. All right, g of x has a negative out in front. That means your a is negative, or your a is less than 0. So that means the parabola is facing down or reflected over the x-axis. And then the minus 2 means it's also being moved down 2. So g of x would match with example 5. All right, so that leaves us with h of x and j of x, which visually we looked at and we said they're not in the right form. Okay, but h of x and j of x are both what we call perfect square trinomials. They're perfect square trinomials because the negative 4 in front of your x divided by 2 squared is that plus 4. I'm going to say that again. The negative 4 in front of your x divided by 2 squared is the plus 4. So you do have a perfect square trinomial, and how does it factor? X minus 2 squared. So once you get your x minus 2 squared and you get that in what we consider some type of form that we can look for a transformation, since that minus 2 is inside the parentheses, that means we're moving to the right 2, So h of x would match with example 8. And then by process of elimination, j of x should match with example 6, but let's just make sure we can factor it. You have a perfect square trinomial, x squared plus 4x plus 4. That's a perfect square trinomial because the number in front of the x divided by 2 squared is plus 4. So that's going to factor into x plus 2 squared. And since the plus 2 is inside the parentheses, that means we're going to move to the left 2, and that does match with example 6. All right. The last two problems on your notes say find the coordinates of the vertex for the parabola defined by the given quadratic equation. And then they give you a specific formula, basically. So their formula is f of x is equal to a parentheses x minus h squared plus k. And I don't know if anybody of you noticed, but if you looked up any graphs on Desmos and you looked at some of their equations, they had their parabolas in this form. I don't know if anybody noticed that. If you looked up other graphs that Desmos had created, their parabolas were in this form, not the form that we studied in Chapter 10, because this form is solved for y. And it's just a common way to write a parabola if you can solve for y. F of x is like a y. So a lot of times this form is used for your parabola that either goes up or down. Just the one that goes up or down, because that f of x is like a y. So the y is not squared in that equation, but the x is. So this parabola could only go up or down. So example 9 is already in this form. Okay, what is acting like the a value? The 2. Okay, what's acting like the k value? I skipped the h for a reason. What's acting like the k value? The negative 3. And then the h value is not positive 4, but negative 4. Because if you'll notice in the equation, it's an x minus an h, and then it comes out as your vertex as a positive h. Just like everything we did with conics, when we pull that number out of that parentheses square, we always change the sign. So example 9, we're in the right form, so we can just look at the equation and we can say the vertex is negative 4, negative 3. Find the coordinates of the vertex of the parabola defined by the given quadratic equation. So all they're asking you for there is just the vertex. Example 10 is not going to be so easy because it's not in a parentheses x minus h squared plus k form. So we're going to have to do a little algebra on example 10. So what you're going to have to do is you're going to have to group your 3x squared and your minus 6x term together, and you're going to have to like kick the plus 8 out. Okay? You just kind of put it over to the side. It's not going to be part of completing the square. Okay? It's just going to be a constant that has to hang out to the side. So if I take the binomial 3x squared minus 6x, can I take the negative 6 and divide it by 2 and square it? No, why not? There's a number in front of the x squared. So before you can complete the square on your 3x squared minus 6x, you have to factor out a 3. And that's going to give you x squared minus 2x. Now with the binomial x squared minus 2x, you can complete the square. So you're going to do negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. Alright, here's the kind of weird part. So you just decided to add a 1 to your equation. But the 1 that you added is being multiplied by 3. So you didn't really add 1, you added 3. But you can't go over to the left-hand side and add 3 because the left-hand side has to stay g of x. So if you add 3 on the right-hand side and you want to balance that out on the right-hand side, then you have to do the opposite and you have to subtract 3. If you're balancing on the same side of the equation, you have to do the opposite of what you add. So then your trinomial will factor into a binomial squared. 8 minus 3 will give you a positive 5, and your vertex will be positive 1, comma 5. If you add a 3 on one side, then you have to subtract the 3 on the same side to balance that out because you're balancing on the same side. Y'all have not done that before. Okay, you usually add on the left and then you add on the right. But if you add on the right, then you have to subtract on the right. If you subtract on the right, you have to add on the right. Always do the opposite when you're balancing. All right, check your calendar for your homework.